the reason we were going to talk about Dijkstra's algorithm is because it's an algorithm used to figure out the shortest distance between 2 points, which is pretty easy. Well, other than, you know, the shortest distance between 2 points that isn't a straight line. If you want to find the shortest distance between 2 points that is a straight line, you use the Pythagorean theorem, right? So, but if you want to find the shortest distance where you can't just take any possible path, you got to use some kind of algorithm that can traverse those paths. But before we talk about Dijkstra's algorithm, we have to talk about graphs. And we're talking computer science graphs, not math graphs. You know, math graphs are the ones where you draw a line and mathematical function. We're not talking about those. We talk about computer science graphs. Does anybody here have experience with graphs? Maybe you've taken 430, 440? Nobody? Okay, let's talk about graphs. So the whole concept of a graph in computer science is it's just a series of points which could or could not have a real position. They might just be theoretical points, and connections between them. So let's say if I have a point 1 and a point 2 and a point 3, and here's a connection, and that's a graph. And maybe I'll have a point 4 over here, and then some connections like this. This is just the idea of a graph. A graph is a very abstract idea that is very flexible and can be implemented in all sorts of different ways. So this is the bare minimum needed for a graph. Is just vertices and edges. We call the points vertices and the lines between them edges. Or you can just call them, you know, points or connections. Points and connections, or nodes and their connections, or whatever you like. As far as how this is useful to us, why we're talking about it, we can use this to represent places in the real world, like locations. So graphs can be very abstract, but we can also tie data to them. Like, for example, maybe these locations aren't just abstract ideas of location, but maybe they actually have a placement to them. Maybe this one's at, I don't know, 3, 3, this one's at, it's over here, so probably like 10, 4, this one's way down here, so maybe like 9, 3, and this one's over here, so like maybe, I'm just talking like coordinate plane. If this was real world locations, they could be, you know, latitude, longitude. I'm just coming up with those off the top of my head.
Where are you at?
Something like that. Sort of 3, 9, 3. So we can have these points, these vertices represent points in real space, and then the lines between them become the distances between those points. So if I gave the points real values, so the distance between them would be, I could come up with fake numbers, but we could also use the Pythagorean theorem. This gets a bit mathy sometimes. So our idea for making the pathfinding algorithm would be, we would take our map of campus and say, okay, this point is at this position, and this other point is at this other position, and this other point is at this other position, all across campus. Figure out the actual positions and the distances between them. Depending on how you want to use a graph, you might not even need to know or care about the positions. Maybe you only care about the distances between them. Like maybe we instead just say this has distance 5, this has distance 4, this has distance 2, this has distance 1, or something like that. So maybe their actual positions are less important than the distances between them. Like I said, graphs are a very abstract concept. There's not this one thing that is a graph and everything else is wrong. Graphs are an idea that we can then implement in any sort of way that we want. So we can have as much or as little data tied to these points as possible. For our project, that's probably the positions of the points is probably going to be, depending on how deep you guys want to go about it, at the very least, probably a location name like entrance to business building.
What's this algorithm called?
I'm not talking about any algorithms yet. This is just graphs.
Like this plot?
This is just graphs.
Really?
Yeah, we're just talking graphs right now. There's no algorithm here. We can just have graphs anywhere and anything, it's just points and connections. Maybe the connections have data like distance. Maybe the points have data like location name or latitude, longitude. There are some things such as directed graphs where the line can go one way. But not every graph has to be directed. If we're talking about navigating campus, I don't think there's any one-way sidewalks. But that could certainly be an idea. So that's just the idea of a graph. I know that was a really fast explanation, but is anybody confused on just the concept of a graph? Need any more explanation? What's nice about the concept is that it's very general. It's a theoretical thing. So it really can adapt to whatever form you need. This is just a type of structure that we use in programming. It's not like, it's like a class of structure. This is a big umbrella term for all kinds of graphs. There's all sorts of graphs and all sorts of algorithms and all sorts of ways to use them. And so the good news is that it can adapt to exactly what we want it to do. The bad news is that there's no one thing in computer science that just makes a graph. A graph is not like an array. You say make an array and your computer makes an array of whatever. An array is a very concrete thing. An array exists all the way down. I mean, those of you in my 310 class, arrays are inside of memory actually. Arrays are a very non-abstract thing. A graph, you don't just say make a graph, like you can say make an array. A graph is this concept, it's an object. You have to define it. In fact, if you look up graphs on Wikipedia, they won't tell you, here's how to make a graph. They'll give you a list of, here are common ways graphs are made, with pros and cons, and the efficiency of each operation. So, that means we'll have to write our own graph algorithm. Not as hard as you might think. For the example code I want to show you today, I wrote it this afternoon. I know I'm more experienced, but if I can do it in an hour, you guys can do it in a week, right? It's not that complicated. So, graphs. Yes?
Did you also, when you wrote the program, did you also draw like the visualizations of the graph?
Yes.
Oh, nice.
Let me.
What did you do?
That took longer than an hour. The graph was relatively fast. The drawing it was hard. Thankfully we're using JavaScript. That made it easy. Let me
Not
pull.
great with JavaScript.
Let's see.
Dean,
Yes.
what class did you say graphs were?
Graphs are typically covered. I know they're covered in 440. I think they might also be in 430. I'm not entirely sure on that. I've never taught that. It's a more advanced thing. I made a simple little mock-up for graphs. It's not that clear. Oh, that's the document standard, I think. What is that?
The camera?
Oh, it is the document standard. Okay, interesting. I don't want the document standard. Where's the HDMI cable? Where is the HDMI cable? Oh, there it is. This is the document standard. HDMI. Is that gonna come up? Hello? That's the laptop. I forget. There it is. I made this. So that's a graph. That's a graph of 10 points that I just put down. I just made up numbers for where they should go. In my implementation, the points know where they are. They have a positional value. The lines connecting them don't know their distances automatically, but if you know the two endpoints, you can calculate the distance. Do you guys know how to calculate the distance between those 2 points? If I give you, I don't know, point 0 right there. Point 0 and way off to the side, and point 2, and they're connected like this. Actually, those are a bad example. Pick ones. Point 0 and point 4. Do you guys know how to calculate the actual distance between 0 and 4 here?
Do the arc length of the function.
Do that again?
Arc length of the function.
There is no function.
You can make them, right?
I certainly wrote code. Do you know what I used in the code to make this work? What's the actual math that you used to figure it out?
Don't you, I think you subtract both of the positions. So something like that.
Yeah, you're on the right track. So you find this is math class now. We have some point here. Let's say this is I don't know if it's actually, but let's say this is at 0, 1, and this one over here is further right and further down. So let's say it's at 2, 4, something like that. What's the actual distance between those? Well, you figure out the horizontal distance between them, and you figure out separately the vertical distance between them, and that gets you a triangle, and then you use a squared plus b squared equals c squared. It does come back. Your math teacher wasn't lying. It does come back. If you're in this field, at least. If you don't want math to come back, go get an English degree. So, using these numbers, it would be whatever. Let's say this is our start, this is our end. 0 minus 2 for the x, we get negative 2. 1 minus 4 for the y, we get negative 3. Negative 2 squared plus negative 3 squared equals whatever we want squared. So, what is that? 4, 9, 13. Square root of 13. That's our distance. There you go. That's the math I use to calculate the distance between them. My edges don't know their distance, but they do know what they're connecting to. So if I want the distance between node 0 and node 4, I say, what's the position of node 0? What's the position of node 4? Do this math. That's all there is to it, really. Now, it's the actual coding implementation of the graph that gets a little complex, because again, it's not just like an array. You can't just say make this. But unlike an array, you can have lots of types of graph. Like I said, you can have graphs with data in one place, you can have directed graphs or undirected graphs. You can't have multiple types of array. An array is an array, you just make an array and that's it. It's a very concrete thing.
So is the 0, 4, or whatever just arbitrary then?
Yes. That is the order that I
You're
made.
just calculating their distances?
Yes. I just made up the numbers. The order of the numbers is the order I created them in. And I just made up numbers. So it just numbered the nodes. That's how I made this one. As for the distance, as for the positions and the distances, in my program, it will actually look at the x, y position inside of that frame and calculate the distances that way.
How'd you get the positions of those numbers?
Like how I decided 0 is in the top left?
No, like, how do you know exactly where it is? The number of pixels it's calculating?
Yes, it's measured in pixels. I've got a canvas here, the big square is a canvas.
So the top left is 0, 0?
Yeah, so up here is 0, 0, and then count x going positive and y going positive down. So node 0, I think, is at like 30, 30, or 40, 40, or something like that, just counted by pixels. The whole thing is 500 by 500, I should say. I can show you the HTML, I just made it with 500, height 500.
And so the root 13 would be the weight, like the weight value?
That would be that would be the actual, if 0 was at position 0, 1, and 4 was at position 2, 4, square root of 13 would be the actual numeric distance between them.
Yeah, but the 0, 4 don't matter.
Yes, correct. That is, the number on the node is arbitrary. I can change that if I want.
That's not a weight of the node.
No. I just numbered it here. I can remove that if you want.
But why? I thought the weight of the node was the point.
Well, there is no weight of the node. The nodes are just, they just have a position. Now again, there are multiple types of graphs. Maybe there is a type of graph where the nodes
But
have
for
a
like
weight.
the algorithm, aren't they supposed to be like nodes with weights?
The edges, the distance. What's important is there's a distance between them. In mine, the distance of each node isn't written down. It's actually just calculated by their physical placement in the canvas.
Well, what's the point? Like, I'm sorry. But like I'm hopping ahead, I guess. I'm not understanding how you're applying this to the formula.
Every line between the graphs does have a distance. They know their distance. It's the actual like measure in pixels distance between them. My program, I said all of these nodes have a position, 0 is at some position, 2 is at some position, 6 is at some position. If I want to know the distance between them, I literally calculate the position. 0 is here, 6 is here. Do this and get the actual distance between them. And it does that. I mean, this math may be hard for you, but the computer does it in an instant, so I just do it on the fly. I don't store the distance. The nodes store their location, but the distance between them, it's just, bam, just calculate. A squared plus b squared equals c squared. It does that in a second. Less than a second.
So the distance would be the center of, for example.
The exact
0,
center, yes.
The exact center, and then that outer circle kind of overrides that line.
Correct. The actual nodes are an individual pixel position. I draw them as circles so we can see them. If I were to get rid of the circles, it would just be lines coming into corners. I just drew that for the meaning of it, just for the visualization of it. Okay. Everyone kind of understanding the idea of a graph, just in concept. We can actually, we'll look at ways to implement graphs in a second. But that's just the concept of a graph. Now, if you're given a graph, let's say this graph represents our campus, and each of those nodes is a point in real space, and we actually measure out the real distances. We're not just making them up. We measure out the real distances. How do you find the shortest distance from one point to another? Let me ask you guys this. On that actual graph, looking at the actual pixel distances, what is the shortest path from node 0 to node 7? Node 0 in the top left, node 0 in the bottom left.
Sorry, would it be more helpful if you displayed the number on the, or the distance right on, if you label the edges with the distance?
It could be possible. In this case, in the case I'm asking you, it's actually, you can eyeball it. There's no abstraction here. It's literally the distance that they are on the screen. This is to scale.
Okay.
So this is to scale. I certainly, a lot of graphs certainly would be nice to have the distance written out like I did here. I coded this afternoon.
So it would just do 0 to 7.
Yeah, so what is the shortest distance between node 0 and node 7? What path do you reckon? 0, then 2, then 7?
Isn't the 0 to 10 5 to 7 faster?
0 to 10, 5 to 7?
That's what I would say.
Should you go 0 to 7 and what
Well,
you're going to
Okay, make your guesses. Because I've written up Dijkstra's algorithm and it will highlight it for us.
I just go with 0 to 10.
0 to 10 to 5 to 7? Yeah. It's certainly more jumps than 0 to 2 to 7, but we're not counting number of jumps. We're talking the actual physical distance, the shortest path.
Is this like an NP complete problem or finding the shortest distance?
I don't think it is. It's not a hard problem. This one's a solved one. It's not too hard. I don't recall. Gosh, I tried so long ago. Is NP complete faster or is it unsolved one?
0 to 10 to 7.
It's not. This is not a hard problem to solve. This is Dijkstra's algorithm is an efficient algorithm. Okay. So you guys have your guesses. Which one's the shortest path?
0 to 10 5.
Let me jump over to the code. All I have to do is say, do
You gotta run
Dijkstra
it,
true,
you're gonna tell
it'll
us.
do it.
Mr. Dijkstra is going to tell us.
Yeah, okay. You guys have your guesses as soon as I refresh them. You guys ready?
Oh, I got it.
That's the shortest distance. Any other distances you want to find as the shortest? What do you reckon is the shortest between 3 and 2? Bottom left to top right. Is it? No, let me get rid of that orange line. I could have made this code better. Bear with me, I had limited. Okay, there we go. 3 and 2. What do you reckon is the shortest distance?
3582.
3582. Not 310 46. Now let's see. I was at least good enough. Let's see. It was from 2 to 3. Is that it? Or 3 to 2? It doesn't actually matter. It doesn't matter the order. It'll just figure out the distance between them. So, and then do true. All right. You guys have your guesses from number 3 to number 2, or reverse. It's the same both ways. Here we go. That one. So we could do any of the two, and we could also make more points and move them around if you wanted to figure out exactly. We could change the edges. So, for example, how about this? What if let's take out the line, take out the drawing real quick. So we're just looking at the basic graph. What if I cut out the distance between 2 and 8? You can no longer go 2 to 8. What is the shortest distance from 3 to 2 now? Would be 3, 5, 8, 1, 2, or is that extra distance now make it longer than the 3, 10, 4, 6? Yeah, it can't, here, let me actually get rid of that one.
The weight.
3 is from 8 to 2 is this one. Just cut out that connection over there. All right, there we go. The shortest distance from 3 to 2. You're right. The program can calculate it like this, but what do you think? 3, 5, 8, 1, 2, 3, 10, 4, 6, 2. 5, 1, 2, just skip it. Oh yeah, 3, 5, yeah, that's true. Why 3, 5, 8, 1, 2? 3, 5.
to take.
Much shorter. It's hard to eyeball, isn't it? But because this is exactly to scale, the computer knows the exact shortest route. It'll be able to calculate it like
Find the
that.
shortest distance.
So you guys have your guesses?
So on the map of the college campus.
Okay.
Say, I wanna go here.
So it's still going from 3
Where
to
you are,
2.
and you click it.
Dijkstra
It's gonna show you the shortest distance.
Save it.
Instead of.
Here we go. Let's see, refresh. It's actually not one. That's now the shortest route. And it's doing the calculations on the fly, so it is actually the shortest route. So that's how Dijkstra's algorithm is useful. If we have the real, either the positions of the nodes, which is what mine has here, or just the distances. All you really need to know is the distances. Mine calculates the distances from the positions, but all you really need to know is the distances. And it'll be able to find the shortest path. In fact, what Dijkstra's algorithm does is it doesn't just find the shortest path between any two nodes, it finds the shortest path from one node to every other node. I just only highlighted one of those paths. So, since I'm starting at 3, it's actually finding the shortest path from 3 to everywhere. It's just, not highlighting them. Oh, I said, please only highlight the distance to 2.
Is it finding the most optimal solution every time?
Yep. It finds the shortest.
Is this what Google Maps uses?
No idea. Google
Yes,
Maps has
if you Google, that's what they'll say.
If they say that's what it is, then I trust them. Like,
That's what the word on the street is.
yeah, I would believe it.
That
It's
this
just,
is the algo.
their graph is just extraordinarily complicated, where literally every point you can be on the map is,
It's
like,
whatever.
they have databases upon
Like,
databases of
any-
just
any
the
efficiency,
latitude and
like,
longitude that
doesn't
could be at
matter.
any given time. But then distance to distance, if they have that full graph, it's just run the algorithm. Granted, if you have a giant algorithm, it is going to run a little bit more slowly. Mine is short because I have 10 points. So,
Well, I'm sure theirs is segmented somehow.
yeah, they was the king of optimization.
Can you, write the name on the board?
Dijkstra?
I don't know how to spell that.
But how does it work? What does the algorithm
Yeah,
do?
talk about it. D-I-J. D-I-J-K. D-I-J-K-S-T-R-A. Dijkstra. It's a name, so it's Dijkstra's algorithm. Okay. So, how does Dijkstra's algorithm work? How is it actually finding the shortest distance between two points? Well, the way it's working, I guess I'll have to use from the board. So, what you do, I'll erase the, so let's come up with an example shorter graph that we can work with. Let's say, that would be good. Let's say we have this node here. We don't actually need to have anything on the nodes as long as we know their distances. So let's say we have these like this, here, here, here. Sure. And we need to know distances, so I'm gonna make up numbers, so this is not to scale. Let's say 1, 2, actually no, let's go 1, 5, 2, 6, 3, also 2. So not to scale, obviously. The 6 line is not as long as 3, but all we need to know is those numbers. So for Dijkstra's algorithm to work, I'll walk through it. And while I'm walking through it, you guys can watch the GIF on Wikipedia. The way Dijkstra's algorithm works is we specify a starting point, and it slowly grows out following all the connections and keeping track of all the distances to all of these nodes. I think I am actually going to want some numbers on these nodes now that I think about it. Just for our purpose, the computer would not need them, but we want to keep track of what node is what. So let me redraw this with some numbers. These are just for helping us keep track. 1, 2, 3, 4, and 5. So let's say we want to find the shortest distance between 1 and 5. Now, I think we can do this one by eye, right? The fastest way from 1 to 3 is to go through 2, because it's 1 and 2 instead of 5, right? And then the fastest way to get from 3 to 5 would be that way. So, but how does the computer figure that out? The way it works is we set all of the nodes. We keep track of the distances that all of the nodes are from our starting point. So node 1, node 2, node 3, node 4, node 5. Each one of them has a distance from our starting point. And each one knows, if I were to follow the path back to the starting point, what's the next node I go to? So if 4 wants to get to 1, if we're finding our path from 1 to 5, what's the first step to get from 5 to 1? It'd probably either be to 3 or to 4. All they need to keep track of is the next step. And then that node will keep track of the next step. And that node will keep track of the next step until you reach the source. So each node keeps track of its distance from the source and the next node on the path to the source. So let's say our source is going to be node number 1, and we're going to try and find the distance to node number 5. So what we do is we say all of the previous's, we haven't found anything yet, so all the previous positions, they're all null, we don't know. And all the distances are infinity. So before we run the algorithm at all, we're starting at node 1. It takes infinity distance to get everywhere, and we have no idea what the path is. Then we say, okay, without looking at any other node, we know there's one node. We know the absolute distance to node number 1, and it's node number 1. Node number 1 is 0 away from node number 1. Oh. Node number 1 is distance 0 away from node number 1. Now, we go to the graph and we just say, okay, let's go through every possible connection. We actually need to keep track of what nodes we have and haven't visited yet. So, when we start, the unvisited nodes is all of them. We haven't actually done anything with any node. So, unvisited, 1, 2, 3, 4, 5. This is all just 7. All the distances are infinity except for the one that we're starting at. All the previous nodes in the sequence are unknown. And all of our unvisited nodes is all of them. Now we enter a loop. The loop is, step 1, start with the unvisited node with the shortest distance. So out of all of our unvisited nodes, what is the one with the shortest distance currently? 2. Don't think ahead, just look at the distances list. Your choices are either node 1 at distance 0, node 2 at distance infinity, node 3 at distance infinity, node 4 at distance infinity, or node 5 at distance infinity. Which one's the shortest, has the shortest distance? It's going to be 1, right? Okay, so we start with node number 1. We are visiting node number 1. It is no longer unvisiting. We are here. What we do is we look at all of node number 1's connections, which could be 2 and 3, so these connections, and we're going to compare them to the current distances. So our current distance to node number 2 is infinity. But here we see we can get to node number 2 in 1. It takes 1. 1 is less than 2. So we found a new shortest distance, haven't we? So we update this. We found a new shortest distance. It is a distance of 1. And this distance came from node number 1. So the shortest way to get to node number 2 from 1 is a distance of 1 going through node number 1. Make sense so far? We now go 3. 3 is also connected to 1. We have to compare this one. Okay? It has a distance of 5. Is that the shortest distance so far? It is, right? 5 is less than infinity. We're only looking at node number 3. What's the shortest way to get to node number 3? It's either infinity or 5. Well, it's going to be 5, right? The shortest way to get to node number 3 from node number 1 is 5. And the path from there, where does that take us from? Node number 1. And that's all the connections on node number 1. So node number 1, checked off the list, we're done. Never have to revisit node number 1 again. So now, we go to our next unvisited list. So from nodes 2, 3, 4, and 5, which one has the shortest distance we've found so far? 2, right? The distance of 1. So 2 has only 2 connections. One of them is to node number 1, which is already visited, we don't have to bother. The second one is to node number 3. Okay, so we can get to node number 3 through node number 2 with a distance of 2 plus 2's distance of 1. So to get to node number 3, we could do 2 plus its own 1, which would be 3. So is that total distance shorter than 3's minimum? It is, so that's the new minimum. We now have a shorter path to 3. The shortest path is now a distance of 3, 2's 1 plus the connection of another 2. And the shortest path takes us through 2. Is everyone following so far? All we have to do is now continue visiting node number 2 now. Okay? So what's the shortest, the unvisited node with the shortest distance? Unvisited is only 3, 4, 5. So of these 3, which is the shortest, has the shortest distance? 3, right? I don't mean to sound demeaning. This is what the computer's doing. It's asking these questions. So we're now visiting node number 3. Node number 3 has a lot of connections. A connection to node number 1, there's no way that this is going to be shorter to node number 1. That going through 3 to get to 1 is shorter than 0, so ignore it. To go back to 2, we've already visited 2, it doesn't matter. But we do have a connection to 4 and 5. So the connection to 4, we're visiting 3, so take this off. The connection to 4. So if we go from 3 to 4, the distance, the total distance to get there, would be the 3 that it took to get to number 3, plus this other 3. So the total distance to get to 4 would be 6. Is that shorter than 4's minimum distance? It is, so we mark it down as the new minimum distance. It was 3 plus 3, so it would take 6 to get to number 4. And we now have the path to it goes through node number 3. All right, we also have a connection from 3 to 5. So it takes 3 to get to number 3, plus another 6, so 9. Is 9 less than the current minimum tracked? It is, so this one, it would take 9 to get there through number 3. That's the shortest path found so far. That's all the connections on 3. So now we move on to the next unvisited node. What's the next unvisited node with the shortest distance? It's either 4 or 5. It's going to be 4. So we go 4. So 4 only has, well, has 2 connections, and one of them we've already visited. So it's just the connection from 4 to 5. So to get from 4 to 5, it would be 4's distance of 6 plus another 2, 8. Is that a shorter way of getting to 5? It is. 8 is shorter. So we update this. This is now a distance of 8, and to get to 5, it's going through node number 4. And then that's we just visited node number 4, we now do node number 5. We would go through node number 5. We don't tell I suppose we could tell the program to stop, but it's kind of already done anyway. It has two connections, we've already visited them both, no more unvisited nodes. We have not visited every single node, and so we're done. So now we have the distances, this is 0. Actually, no, it's not, it's still a question mark, isn't it? Because node 1 doesn't come from anywhere, that's our source. So now we have the distances from node 1. So to get from node 1 to node 1 takes 0 distance. To get from 2 to 1 takes 1. 3 to 1 takes 3. 4 to 1 takes 6. 5 to 1 takes 8. And the path, well, we just follow it one at a time. So to get from node 4 to node 1 in the shortest distance, 4 goes to 3, 3 goes to 2, 2 goes to 1, and 1 is where we end. So what we would end up finding is the shortest path from node 1 to node 5, because we said 5 was our destination, right? The shortest path from node 1 to node 5 would take 8. It's a distance of 8, and that's the shortest path. We've already found it. And what path does that take? Well, we actually track it in reverse. Starting at our destination, we would have to come from node 4. And then from node 4, we would have to come from node 3. And then from node 3, we'd have to come from node 2. And I didn't mean for them to count down like this, but they just did. So that's the shortest path there. That's Dijkstra's algorithm. We can, here.
It's crazy.
I've walked through the whole thing, but.
And that's what Google Maps does, constantly.
And in fact, we can look at the, what is it? Pseudocode. There's the pseudocode. That's the pseudocode. And I mean, the real code's not going to be too much longer than that. So it's really not that complicated. Maybe it is complicated, but it's not that complex, I should say. It's hard to understand, but it's not hard to write. And so you can see that GIF is doing it on a much larger graph.
So just to clarify, like, functionally, is this the same as a breadth first search, but using a mini instead of like a stack?
Kind of. So it's not really the same as a breadth first search because a breadth first search is done on trees, and trees don't have a distance between their nodes, or between their branches.
Yeah, here I think it's just going for whichever is the cheapest every time. It'll go cheapest every time.
I believe we can call Dijkstra's algorithm a type of greedy algorithm. It's always
Yeah,
going to go
that's
for
the
the
word.
smallest. It's always going to try the smallest. And again, technically, the real Dijkstra's algorithm will just do the whole thing. I mean, if you have if you're not, unless you're Google and you have to limit like, somebody's movements to the county they're in and not the entire surface of the earth, chances are you could just do Dijkstra the entire thing, and you get. I mean, we were trying to go from 1 to 5, but we actually got the shortest path for every single node to node number 1, and the path from every single node to node number 1. That's actually how the program I showed you, that's how it does it. It just does the whole damn thing. I say, here's the starting point. Find the distance from every node to this point. And then I say, okay, now that you've found that, here's the destination. Just trace back its shortest path. That's really all it takes. Conceptually, I hope that's not too hard. I know can be a complicated concept. The real challenge comes in when you try and write it into code. So, any questions on this? I can share my own program with you guys so you can try and mess with it yourselves. Here, I've got, just to show off the code real quick. Here's the HTML. It's some JavaScript scripts, the title, the graph, and then the canvas, and that's it. As for the code itself, I'm using object-oriented design. Here's the graph. Like I said, there's no built-in graph. It's not like an array. I had to make this. So to be honest with you, I used the pseudocode on Wikipedia, just because I didn't want to have to remember it all. It's a lot faster to just get an overview. And then This file has everything else to make it work, which includes this create graph is where the graph is created. Here's the 10 nodes, and here's all the connections between them. I've got a bunch of helper functions. This sets up the actual display. Here's Dijkstra's algorithm. That's it on screen. That's the code for Dijkstra's algorithm. It's really not that much code, is it? It's about as long as that pseudocode was. All I'm really doing is keeping track of the distances. I've got a bunch of JavaScript arrays to help me keep track of all the distances.
So there's 3 arrays?
Yes. One for the distances, one for the previous list, and one for the unvisited. I called it remaining. So it really is, like I described it to you here on the board. It's not that much more complicated. It's analyzing the algorithm where the complexity comes in. It's like, oh, is this algorithm faster than this other algorithm? Oh, what is the technical terminology we use behind this algorithm? That's where it gets all complex.
I don't know, the greedy one just works. You'll be tripping.
And conveniently, JavaScript actually has built-in infinity. So I can just use that. JavaScript is actually kind of a convenient language, really.
Yeah.
Yeah. And I think the rest of this file is just all the code to get everything to draw. So this is the part where it draws the path. You can see I set the orange. Where it draws the Dijkstra. I have the unvisited list. You have to visit in the short, this node with the shortest distance first. So I have to keep sorting it. Helper functions. Here's the get distance. Here's a Pythagorean theorem. There it is.
And so this could just scale up, huh?
Basically.
Right, the algorithm's ready to go.
Yeah, I
Just
mean,
make the
if
array
you
bigger.
wanted to sit here making nodes, I mean, I only made 10, but you just sit here making hundreds of nodes and just adding them to the graph.
Well, if we just plot those 2 points on this map here at the school and make up some values,
Basically.
it would technically give you the shortest distance
Yeah.
based on your guess.
I would not recommend using my code as an actual base. You're welcome to use it as an inspiration, but I would not recommend using it as an actual baseline because I made this in 3 hours. I make no guarantees as to its scalability or
I
its
think
efficiency.
you could keep cobbling this bad boy.
I mean, you might be able to. I would not trust it. I say I made it in 3 hours. I made it in 2 hours and then spent an hour fixing problems. There was a bug where it kept drawing everything orange, and I didn't know why.
Yeah, those aren't even related to the algorithm.
I know, but it kept doing it. So either way, I think, yeah, the original and everything, yeah, here's the actual drawing of the graph. So, yeah, that's it. Here, let me zip all these up and you guys can get them on the Discord.
Nice. Just one page, you just load the text.
No, it's 3 pages.
Damn.
We can use it. What?
Discord.
Sorry.
Resources. The resources channel.
No, we said
right?
he used some.
Got it from Wikipedia.
Not all of it.
We should make a new channel.
There we go. So you guys can mess around with it on your own, look at the code. I would say honestly, it was harder to make the graph than it was to make the Dijkstra's algorithm. Dijkstra's algorithm is not the hard part. It might sound that way because of the name, but it's really not. It's the graph that's the tricky one. Because
It's like the methods you have to make.
yeah, a graph isn't a thing. It's not like an array. You can just say make an array, and it's with a graph, it's just a concept. You have to make the graph, and so everything you want the graph to contain and to do, you have to do. That's why I would say don't use my code as a base. I just used a bunch of ugly arrays, and it's.
It's ready to go.
So you know how the nodes are numbered? If you delete a node, it'll actually renumber all of them. So I was coding fast, so don't use my code as a base. But definitely experiment with it. So if you guys do want to mess with it and just mess with the graphing parts, in draw.js, just this create graph part, you can create whatever nodes at, these are actual X and Y positions. Here's the connections, you just say node numbers. Connects
Okay,
node
so
0 to
the
node 2.
values are based on like distances from each other? You can't
Yes.
just like put the values in like you did over there?
Correct. I did not, in my implement, I was coding fast, so I literally just said, this is to scale, find the distance.
Based
between
on
the two points.
distances between each other, you can't just give it a rudimentary value.
No,
They have to be a certain
Yeah,
distance.
I did not code it that way. It's certainly,
If you give it a
certainly,
6 between the 5 and the
Certainly.
3, you would have to get the distance of 6 between the two of them.
yes.
Or whatever you
That's
said.
how you would do it.
Yeah, so certainly, like I said, we can't just use this as a baseline. If you want to try and make it work, it would be harder. This wasn't well thought out code. But, so yeah, but you could just as easily make a graph if you do keep track of all the images. In fact, if we were going to do it for
But
campus.
just do a node with 2 arms there or whatever, and
I
then you
mean-
get those weights.
Yeah, I mean, for the one around campus, I would probably say we don't actually need a position of any given node. All we need is the distances between the nodes and where on the map the node
You
should
could
drop.
legit just open the map right now and just do dots and then guess the values, and there it is, that's your map, that's your nodes.
We could,
Those are your nodes.
but it'd be a guess though.
That's all, it's pretty good, I think.
So how would we do this? Like, we go just pick our own nodes and then we just measure it
We get the
ourselves?
data for our graph. We say, okay, this node represents the entrance to the natural science building. And so this is where this is. And okay, what's the distance between walking from the entrance to the natural science building to that junction of the sidewalk right there? We get that distance, we note it down, we can use it in our code for the future.
Yeah.
And then we can, once we have all that data, we code it into an actual graph.
Right.
And then once it's in a graph, we just run the Dijkstra Oct on it. And it'll say, okay, start here, go here, here's the line.
The way you're saying, we'd also tell them like the actual distance, right?
Yeah.
Otherwise, you could just kind of place it on a graph and figure it out.
Yeah, so we could probably want to also tell what the distance is. Like, what is the distance from the natural science building to the library?
But, yeah,
All we have to do is measure it. And we don't even have to measure it once, just measure it between every little junction of the sidewalk.
But like that node of that entrance has to connect to all the other like pathways that we know we can into,
Yeah,
right?
all the
But if
ways
we
that you
go to
could want
3
to.
different locations at once, then all 3 of those have to be tracked
Yeah,
in the algorithm instead of the 2 here.
yeah. Any questions? That's all I had to show. We can-
How-
Can you pull up the school map?
Yeah, and
Yeah, how-
draw the nodes,
how do
the
you-
nodes, Professor.
How would you go about overlaying the school map over a
Right.
graph?
He's gonna do
Getting
it right
it to
now.
scale properly?
Getting it to scale properly is one thing. I know with Java canvases, you can't just draw images on them.
Really?
Yeah.
That means
So,
Canvas is doing it for you?
Yeah, I mean, it's a convenience.
Well, we
tool.
could just get the map, find out the coordinates on it, and then just draw the nodes on those coordinates with the map being displayed in the background.
Yeah, unless we wanted to draw our own map. but-
I do have coordinate data. I've actually been tracking it as I've been going around campus. If I.
Oh,
if
we
people-
can build it now.
If I'm okay
Hold
with-
on, let's get to points, and then you can write up
Yeah.
distances.
Yeah,
We can do that.
But we can try to apply it
Yeah,
using
this-
distances on the grid.
And I think I've demonstrated to you all that I am
Massive
certainly capable of doing this.
satellite.
Uh-huh.
I'm not gonna be doing it. I want you guys to do it. I will help answer questions and help.
Shall we break into groups and attempt to
I mean, I've only taken up an hour, let's,
map some nodes or something?
Yeah, try it.
Anybody got a printer? We could print like maps for people, or do we have to draw them by
Did somebody
hand?
bring a printer in their backpack?
Yeah, anybody got one of those portable ones? I've seen them around.
Guys, yeah, what, we need like a measuring tool?
No,
Those
it's like,
walker
we already got
wheels?
it.
This is that they've been measuring.
Yeah, or
Oh,
you
you're
just
using
guess
satellite?
it. Just guess the distances. Using your
I
heart.
was just saying, if people don't mind if I share the data I have as an example?
Yeah.
Just for-
Yeah, for sure, yeah,
Like
let's-
pop up and-
Let's write it out. You wanna put it on
We're
the
using,
board, or?
we're using GPS?
Kind of, yeah. I was
Yeah.
gonna throw it up. I have on my laptop if I can share it. If people are down below.
You wanna do the old mechanical way?
What do you mean? I think we just guess it right now. We can start rigging it instead of
I mean,
bothering to measure.
Here's another question,
Just
do
rate
we
it.
want a more detailed map than that?
No,
That sounds like a lot of work.
It would, but how much work are we gonna put into this project?
I think just do it now. Like, what do we? Rig it. I want to see you can make it work now, right? You could have
It would
the
take a lot of typing in.
Dijkstra's right now can like calculate from LRC to PAC or
I've
whatever,
been
right?
saying the algorithm's same for weeks now. It's Dijkstra.
Dijkstra. Dijkstra can start doing it now. Then you guys are like, no, we're gonna draw. Like, what are you talking about?
What do you mean by more detailed? Like,
Well,
Like maybe like doorways?
Yeah.
I mean,
What if we film the entire?
I mean,
campus and
when I say
then
what
stitch
you
it
know, I
together?
mean literally
And then-
anything other
and
than
play that
this.
video
I mean, are we gonna
yeah.
map out, I mean, look at this little webbing of sidewalks in here. This is as much detail as we have to work with on this map.
That's pretty sick. We have those on the.
Yeah, it's pretty nice and already on there.
The webs are real, by the way. You can walk those.
I mean, would
It
we
is missing
prefer?
a couple.
I mean, I'm just throwing out ideas, I mean, it's your guys' project, I mean, would you guys prefer to go Google and get a satellite view of the campus and draw onto that? I mean, it wouldn't have to be a live satellite view, it's like,
How many nodes can we have before we start having to worry about optimization?
I highly doubt,
It doesn't-
I'm pretty sure we could get every single
Yeah.
junction of the sidewalk, probably every single hallway in the
Yeah.
buildings.
Google.
And it probably still would take less than a second.
Yeah, 'cause,
Computers
like,
are fast.
Google
There's nothing
uses
to
it
Google
for
Maps,
maps.
go
Like,
ahead
think
and
about
map.
that.
Like,
How many nodes do you think they
There you
sell?
go. We have their open source tool,
They
and
have
map
like
link ones.
unlimited nodes, dude.
I don't think so. You
So,
You
I
know,
mean, it's
like,
up to you guys
infinite
how
nodes,
in depth you wanna
just
go with this. If
infinite
you guys,
nodes, dude.
if you guys measure the distance from here to the library and you say you're good, I'm not gonna stop you. But if you guys wanna actually get the distances to all of the points, we're gonna have to measure all the points and make sure that our graph, our map rather.
I think we could do like 5, 6 big ones, and then just apply the algorithm and just have it do it right now and draw it like.
5
you
and
do.
6, we're gonna be going over buildings.
Do you mind if I pop up and show what I have? Sure. It might give people ideas too.
Yeah. I mean, just the entrance door to every building here, I mean, how many buildings do we have? Like 30?
No, I mean, like, we do 5 buildings, and then the way you had it drawn with the circles, right, you just put the circles for those buildings, and you can route them based on our guesses of distance. Except his, yeah, his use of pictures.
So this is where I say, I've deceived everyone, grab pen and paper, we're going out and mapping right now.
Oh, boy,
No? No?
people are ready.
I'm ready.
Okay, well,
I can use the exercise.
presumably,
You're on the
I'm
wheel.
assuming most or everyone here attends class, right? So you probably have to park or public transport and walk to class? Maybe every day, maybe every other day? I have one class every day, so I'm like, I have to walk to class every day. If I had something that could track me, that could keep coordinates and maybe distance and time, maybe, maybe I could come up with and keep track of that. And actually map it out.
So we should track all of the books.
We don't wanna see Alex track, we gotta track like, it's
We
like,
track all of the club students, we should just enable it, no, we want to.
instead of trunk or treat is like behind the
So,
lines.
this is an open source tool called GPX Studio. It lets you look at and modify GPX, which are GPS coordinate files. And I have between my phone and my watch, sensors, trackers, GPS trackers that can track me and follow and keep track of all of the coordinates when I'm walking along certain paths. The blue path was October 9th. This would be the path I normally take to get to, I have a biology class here, so this little flag mark up here, this is where I start in the parking lot, I'm kind of where I park on the far side of the parking lot. And I walk that entire distance all the way down. And then the red one was actually the one I did just before coming to club because I wanted to collect more points and I'm tired and sweaty. But these files that I have, if they'll open up and play nice, no, that one.
GPS coordinates or something?
Yeah, look at that, this first one. It's got my latitude, my longitude. It's even got the time.
At each one.
So it's keeping track of time at each point that I'm walking.
That connects.
And then even more, even more details like how fast I'm going and whatnot. Well, I can pull all of these. And I have, it's already out, I have a little bit of a parsing algorithm because it's in XML tree. So I can just parse through these coordinates and filter them out, and I have, for a given coordinate, here's latitude, here's longitude, and then the time. And I can see that from this latitude point to the next latitude point, this longitude point, the next longitude point, because it's keeping track of
This
my
was so
time.
perfect with Gideon's program, because
It's
he
1
literally
second.
uses latitude and longitude.
So every second, it's keeping track of what point I'm, and this is actually
They're
simplified.
built for each other, and it'll work, right? If you do the x, y minus from each other, it'll give you the
Yeah, exactly.
difference.
This would be the distance, and
Just
this is
like
also
the
massively
program.
pared down, like, the tracking, GPS precision by default, at least on Apple hardware, it's like 14, 15 digits, it's like down to like millimeters. So I looked up and referenced, I believe 6 digits for GPS coordinates is down to like a couple inches, which, you know, I don't think we need millimeter level precision for where we're putting our points.
Yeah, we certainly could do it.
could, yeah.
How many millimeters are there between the library and the?
Couple inches.
Exactly.
You say it would be off by several inches, it's crazy.
I mean, that's
Think of
project
the
creep right
think
there.
of think of the children, you can't have that kind of imprecision on our school campus map.
I was hoping I could have the entire campus walked and mapped out by today. The rain the past few days, I haven't been able to walk around, so, but yeah, so this, an option if people want, and if people also have at least Apple devices and want to track workout data.
I mean,
Additional data points, because not only that, again, it tracks the speed and the time between points, so we, then we wouldn't just have to say, oh, the distance between the parking lot and this building is however many feet. I am 1'5'9", 120-pound person, for reference point, we could say, oh, it's probably going to take you this much time, because we have time as an additional reference point. It's going to take me
We'll only
however many
use
seconds to get from point A to B. So,
Nice. That's-
and then this tool specifically, we can even put and go ahead and say, we can assign the
You don't have
waypoints.
to
For
get
your
the-
weights.
So we can like put waypoints as points of interest, and then, have those points have the coordinates there, and then just reference it with the data. Oh, this waypoint is close to this, where someone's been walking, so we'll just aggregate that. Question?
Yeah, so, would the map that we build link to this so we can track how long it would take? Because, everybody walks differently, at different speeds and stuff. Or is it like an average? Based on you?
Every single point that was shown on that list, that's another node.
Yeah, so like all the points that would be on like these two trails that I have,
Yeah.
that's all of these.
No,
So
I'm saying,
they look like squiggly real walking lines, but they're really tracking the points. It's 1 point every second. So in a zoomed out view like this, it looks like a squiggly line.
I mean, I would just say that.
And then even if we wanted, for this tool specifically, we could even reduce the amount of points based on the tolerance. I mentioned like I was using like a couple cases tolerance. So if we wanted to reduce points,
You should be able to.
or increase points, but we can,
I mean, we have to find an appropriate squiggliness to match the actual sidewalks.
yeah.
They,
Some ideas for you guys to think about. I mean,
yeah.
there's
What
no,
would you do?
I don't have like an idea that I want you guys to try and meet here. You guys are the ones who came up with the idea, and you guys are the ones who are gonna envision what it's gonna become.
So I guess the idea I'm pitching is GPS coordinates because we can get a rough enough approximation of distance since we know precision between them.
Yeah.
And then we provide at least however many examples we want, but one reference point for time as well, since I can take the time from, I think this one, yeah, so like this one, from that point, it aggregates all the time points between each coordinate, and it took me like about 9, almost 10 minutes to get from that point in the parking lot to this building.
I like it. It's
Damn,
like
10 minutes.
Ali, can you leave? your
Well, I mean, I consider that like a reasonable walking pace. I wasn't-
I didn't realize it was that long, that's what I'm saying.
Or maybe people are faster too, you know?
That's true.
We want to be ambitious, we could be, okay, how fast
I'm
can
gonna
you walk?
tell mine,
Can you
bro.
run?
Let's
If
all
you're
check
really
our
slow?
library walking guide.
We should include like a, oh, he mentioned we should include like an average walking distance and just kind of divide the distance by that.
Yeah, we'll do an array of everybody's distance.
I'm sure you walk pretty fast.
I mean, if you guys wanna, I mean, it depends on how deep you guys wanna go into it. As long as we have the distance, you can have a drop down or an entry for walking speed.
That's true.
Or you could even like, if you wanna go a level deeper, you could ask someone, what's your height? And try and calculate the average walking speed for that height, that kind of thing.
Well, we could do.
I'm just kind of diving deep into the idea now.
Do the library.
But you could, once you have the distance, we can add as much as you want to it. The features are yours to build.
I don't know. I think we should just rig something small together for starters, something with like 5 points, right? Just like, instead of being grubbed and be like, yeah, I want to do all the points at once.
I
Let's
think
do
it
all
is
of
the
them.
buildings,
So then
do all
course
the
counts, I have like.
and then they just have.
I mean, that's, it's up to you guys.
Next gonna be like, how would we merge all of our points together?
Yeah, I was thinking you could share the code on Discord.
Oh, sure, yeah.
How would we merge all the, he asked how would we merge all the.
Like, if I go on a route and I record some, and someone else goes on a route, how are we gonna merge all the routes?
Are we just gonna do more routes?
This open source tool is one example. We could merge them that way, or we could write an XML parser, like we could clean this, like,
Yeah,
this is shy, but we could clean up a bit more, just to merge all those files together, and then we have our.
Yeah, I mean, the actual GPS tracking is just getting points in the XML file. So we could, you know, write a program, or we're probably beyond getting someone to sift through it by hand. But all you have to do is go through it and say, okay, this point is this position, this point is this position, and you just put that in a big old database of whatever form you like. So probably, it's all in a nice format to begin with, so you can just write a program to it.
That could be even the simple other one too, if you have like just anything that can mark a GPS point,
The-
your phone or something, go to a building, okay,
The
this
trick-
is the point for.
yeah, the tricky part would be, if we can get all of these points, but the question is, what points connect to what other points? Because like, we can have points all over campus, but not every point connects to every other point, you know? A point on one side of the building and a point on another side of the building, you either have to go through the building or around the building, right? You can't just say, oh, they somehow connect. So, you'll have to figure out how to put the graph together.
I think we should have like around the building. It's
Yeah.
kind of, doesn't make sense to tell somebody, oh, go through this whole building.
Our campus doesn't really, our campus is built in such a way that you don't really have to go through buildings to get.
You can
places.
step through the cafeteria sometimes.
Yeah, maybe the
One
cafeteria.
little cut through you could do.
Yeah, but I mean, other than that, like, there's no
Yeah.
cases where you have to like go
I'll do it.
through Rana Hall
Through
North
the
as the
cafeteria.
fastest way.
Yeah.
to-
I'll look at the people in there and they'll walk by.
So we could probably just do outdoor
Is the
paths.
cafe technically?
So we somehow get the data.
Well, it's like-
These are good examples for ways to get the data. Turn the data into
Secret drawer.
a graph, you know? Instead of just made up numbers like this, you say, okay, this is one of the GPS data points, this is another GPS data point, this is another GPS data point. Once you have that graph, it doesn't matter how big your graph is, Dijkstra's algorithm is the same amount of code. It's that one page of code that we saw. So,
Should the source be the parking lot? That's where most students.
Well, it should be the
That's an
crosswalk,
idea.
because it's different.
yeah, I think we were thinking, we'd have like a drop down for, where are you?
Yeah, where are we starting from?
Yeah, where are you starting from and where do you want to go, and what's the fastest way to get there?
I mean, yeah, wouldn't it are, you guys, how would you do current location? It kind of might be.
Yeah, there could be, if you can figure it
Right,
out.
if we have the GPS coordinates, right, so if they can just give
Well,
us theirs and
that, we
compare
have
it.
a database of GPS coordinates, but then we could also maybe look up, like, maybe we have, turn this into an app on your phone that says,
Request
what-
current location.
what's your current location, finds the closest point on the map.
Because we have the actual,
Yeah. And so then,
and snap, you do it, oh my god.
How did you track yourself walking?
So for Apple Gear, any workout I have an app called,
I mean, does JavaScript already have a current location built in?
Now,
No,
There's
they're
probably a
requested. I bet HTML have like a request,
Apple is a little
Current
freaky, but there's an
location.
app called Health X, what's it called? Health Auto Export that will go into your Apple Health data, export it, and then what I had, so like this is, I did a date range from like the first of the month to today, and it has my workouts, my walking routes, my outdoor walking routes, and then yeah, these are just GPX files that have all the coordinates. So I started an Apple workout when I walked here, and there you go. I can't speak to Android.
yeah, just start, walk, stop, and the GPS does the rest, right?
Yep. Other question?
And then, so after you have that worker recorded, how do you make it a GPX file?
Oh, so no, this is literally it.
Oh, okay.
It just exported as it.
Okay.
The export has it as, it says it exports health data as JSON or CSV, but then workout data is just by default, I think, stored as GPX. So this was just pull it, there it is. And then it was just a matter of, yeah, I just had it as this big old XML with all of the coordinates and stuff. And I just wrote a simple Python thing to just give me the coordinates and the time. So, yeah, and then we can figure out how to format it from there. As one example, I mean, I can, like, if we want to throw GPS out the window, that's fine too. I'm just pitching this as an idea.
This is a nice
No, I think.
techie way of actually getting all the data, as opposed to going out with clipboards and, saying, okay, I'm here, you're over there, what's the distance between us?
somebody wants to get a clipboard, just count their steps.
That's
That's also very easy to do.
I mean, that's the thing, is we can decide, I mean, if you guys really
You
want
can do
to
both.
gather the data in a
There's gonna
triplicate
be
and double check
a big
things.
divide in the club between the GPSs and the step
And
count.
the step count.
Yeah, step crew.
Yeah, what's more accurate,
Step
people or
gang.
GPS?
Step gang, don't trust the GPS. Only the foot knows the distance, you know what I'm saying? Not these computers in space. Trying to be my global position.
Wow.
You guys getting ideas?
Yeah, that's the only thing though,
How you
wouldn't
wanna
work with
progress?
current location though, if you did it.
You know what I mean? It would. Oh, it's not supposed to.
So,
It's just gonna go off of your mind. You're like,
There-
oh, you just pretend you know where you're there. And all
are
of
there
a
any
sudden,
questions about how graphs work or Dijkstra's
So it
algorithm?
does work.
No, you'd have to
What are the
use it,
concepts?
you'd have to figure out the GPS coordinates.
The devil's in the
Here,
details.
you at the cafe, go ahead and walk.
You actually start fighting the code, that's what it goes.
This is meteors.
Encountering the
GPS.
I like that app idea.
How does the map work, buddy? How does the map work?
Make it an app instead of a website. Make it bold. That's up to you guys. This isn't a class. You're not gonna get graded. There's no right answer.
What? No, I'll judge you guys, don't worry.
Well, judging and grading.
Don't worry, I'll be in the back.
You know what?
judging. I'll be like,
What do you want
guys,
us to do?
I bet these guys don't even make an app or whatever.
Yeah.
A drop down menu, you're out of your mind.
Alex for president.
I think it's,
No, I'm head judge
Is it not in resources?
and executor.
I forgot to get that. My bad. I thought I did that so much earlier.
What, you're not Phelps or what? You're not?
You, dude. I hear you're pretty good at React and Jade. I wanna see it. You could vibe it. You think you could vibe the algorithm?
Yes.
Yeah,
Sure. I could see
Oh,
it.
no, how to like plug it in. You're like, hey, where's location? Here's locations with like distances to each other, use Dijkstra to build the JavaScript. You don't need GPS data. Basic points with distances from each other. Cafe, library, library to business learning, business to cafe. We're just giving a value. We're going to use the algorithm. It's going to be the JavaScript.
Well, that gives you the distance, but you still want the GPS.
You don't need the GPS, now you're more based on.
Okay.
It's arbitrary, you literally tells you to use.
So the actual
You don't have to
node,
use
you
the
wanted
difference.
us embedded.
You could just use how long it took you. You could legit time how long did it take you to walk from business to library, from library to
You're
cafe.
talking about.
What is the time?
Yeah, the
You
way
wanna
you
do it based on
camera it,
time.
right? You didn't legit use his weight was distance on the screen. You're like, okay,
That
well,
would
now
be-
you
that would be
can just
so
see how
bad.
long it takes you to walk, or just the legit step counter.
No.
And then you can just plug it into the algorithm and it'll work. You just have to correct it.
Yeah.
What do you mean weird? In the array.
Okay, so each
It's right there on the board, it's right there on the board. Right, so if I go, so
Are
instead
we
of
trying to
one,
get
you see
an
how it says?
approximation or?
You see how it says one? Instead of one, I'll say cafe, and then three will be library. And I'll just say the distance between them is 20 steps. And then number two is gonna be this building here. And then I'm like, okay, this building to cafe is 40 steps, this building to library is 20 steps.
Oh, measure.
And then you could overlay the
You
other
can do it
half.
any way you want. Any way you want. This is Burger King food. You could have it your way. So you can go ahead and do it any way. It doesn't matter. I don't even know why it's such a big discussion. I want to use go ahead. You could legit use the pixel distances on the map. How about that? He just take the map and then plot it into his algorithm. Well, according to this, the library.
Oh, no, for it.
And it's you gotta watch out for it. Are you on it? Are you vibe coding this yet? Then I wanna see you vibe code this. I wanna see how far you get.
So you're gonna be writing the text.
Like, the chances are you come back.
You're gonna need a,
Blown away.
you're gonna need
Damn,
a-
you vibe coded this? Damn.
You're gonna need an emotional
Are you paying for
support
it?
role.
Are you paying ChatGPT $200 a month?
No, I only use Copilot and I'll maybe use it like
Who else has some good ones?
20 times.
That I can
So
find.
this one for the Mac is free, GPX Studio, but you have to give it a GPX.
My token usage is free for
Which, you know,
Yeah.
Like,
You've been saving up your token too, right?
Like, yeah.
You're ready to blow.
I spent all my Microsoft bucks on like.
You gotta buy sweepstakes, you gotta buy code. You gotta lose token. You gotta do it.
I mean, do you know how to get to the second
I tried doing that like plant a tree one, that was too much work. I can't think of this easier.
What?
Like plant a tree when you got
This
like
one,
water to seed in.
one thing.
And they really want you to like.
They want you to water
water
every day.
Yeah.
Oh, that's gonna be big request.
Yeah, oh, and then you have to consider too, like, how many people are gonna come across the parking lots, you know, so.
Yeah, there's a couple extra notes.
But this one actually, with this view, yeah.
Do you know how to stop Alex's heckle?
Hecklebot?
You just hit, you can start
Just hit it with
You start vibe coding.
Shield dot win.
Yeah, exactly.
Stop master.
I need to do a vibe code, like, so voice through texting and then have them contact you for 2 hours.
Wait.
I want to do all that. Heckles already here heckling me.
I like it. No, the hecklebot.
Why would ChatGPT take over the job like that? Stop trying to outsource Lynn heckling me. Also, Lynn, stop trying to outsource heckling me.
I just copied and pasted his code.
Yeah. Why don't you start vibe coding? I want to see this app.
What's that, what's the heckle?
Aren't you a coder? I want to see some code. Dude, why'd you bring a laptop? You could as you go through the So you're in a laptop? That laptop packages?
It's kind of easier stuff.
Laptops for business use.
computer they have like. Or like something.
It's 440.
Yeah, tracking. Yeah.
What'd you think of that algorithm?
Yeah, you're right.
80 steps.
Yeah.
Yes.
Pretty good. Well,
Have you taken, that was all taken out of it? What are you,
well, I'm trying to track.
are you pushing back till the end? Yeah. It would be like, yeah.
I should though, but I haven't.
No, technically we're in
I'm trying to
there.
review this networking garbage.
There's no way.
Yeah, so now I'm like knee-deep.
Huh? Oh, yeah, if you want to sign it.
Sorry, like, I'm not gonna say anything else. It's all this right
Yeah,
now.
we didn't get Max to
It's all
speak, so
this
you
right
missed
now.
out.
Yeah, boy.
I think we need to get this one.
Once you do that, it's like, you got both problems. I can't even.
Did everyone sign up?
On the day.
Yeah, but they draw.
Did we just?
Yeah, I'm out.
But I'll come back to the showcase next
Yeah,
time.
it's roughly every second.
Yeah, where's the
Mark
set?
knows where we want.
Yeah, I gotta work on that actually. I'll work on it.
Oh, right, that's why you're saying.
Or even then, we'll create like a general blueprint. We just walk that path. Just track it on the phone.
We can just use this blanket. We can just use this blanket and have the satellite map. We can just pick, okay, where do we want to wait on this and stuff.
I don't think we need to walk the map.
We don't have to walk it. It was just, for me, it was more of a reference for walk that way I did, because distance is one thing. Yeah.
Are you interested in this stuff, or you?
We have to use GPS maps and 3D maps.
Some of these guys are pretty advanced. I'm not.
No, I mean, like, tell them this is like.
I mean, it's just path.
Oh, yeah. So plug all that into a site.
CSP 360.
Mine is gonna sit down.
I mean, nowadays there's so many tools you can use, it's pretty easy to like get basic stuff. I mean, some of the higher levels, so
Is anyone
implementing program there is a little more difficult, but
on that video?
there's a lot of people
I'm good with
using
that.
React right now, which is super easy to use.
Yeah.
for, like, users.
You just had to pick something.
I mean,
We should vote on
no one wants to do
Everyone should want this. I would do this one.
I'm just gonna pass.
Yeah, everything's good.
Yeah.
I'm voting for anything, but I'm against it just because it's so close to.
Pizza, yeah, I mean, well, we have the hackathon, so we go to do
The
the
Axel mentioned like computer vision, right?
competition.
I would say the jump start.
So I'm going to Hornet Hacks this weekend, 3 days. Like, which one?
The drums or the postcode?
Yeah. I think it's like 5,000 in,
I'm not going,
Scholarship.
probably not gonna go with the coach schedule or now that.
No, it's all all this is all voluntary.
I'm worried that.
The only ones that have to be here are like the guys
A pretty, or it's
who are
already
responsible
been
for maintaining the club.
implemented a few times. Voice assistance seems pretty free overused, so I'm sorry to have you put back for buttons.
So, Huh?
I know
Just show up.
there's that ideal.
just as long as you're just student, that's all you're a student. Unless you want to like run it, then you have to do all the
I still think that's interesting.
extra stuff.
Yeah.
If we can't, I know we can't
Yeah,
have
I
the
was gonna have
physicality,
it, I was
that's
thinking that most of the time.
we could still.
It doesn't form as
Still
a
put in data. I wouldn't know how to
Biscuits?
suggestion that data. Like, I wouldn't know what
I can figure out
presentation. But I'll switch over
Well,
What?
You're switching to gun?
We're going to the thermal one, then we basically just like the dashboard. Want to show like just use like a regular thermostat and then one way where you use it.
I only have
Customize it.
the coffee cup
And then
next to me, but it's like, say,
Thermostat data or?
What's that?
You need just the thermostat data or an
We
actual?
can make that, we can make up the data.
Okay.
It'll be something like, turn on at like 3 p.m., turn off.
I mean, if you wanna start the meme on the guy with the hibiscus tea, like, bring it out.
Getting more interesting.
Wait, what do you guys actually?
I'm seasoned, dude. You know, I got Hecklebot over here.
Okay, what do you think?
Which one? I mean, I don't like it. Outside of like the because of like, after that, can we implement?
You don't go to comic clubs?
Or whatever we did.
Yeah, don't worry about it.
Every once in a while.
There's tons of stuff online.
One right
I'm sure I
outside,
could. The problem is we have the time.
and then Folsom.
But we really don't have like a day and a half.
Yeah, that's what I was thinking. I mean, something where.
No, I mean, I'm not,
Whatever
I
we
would
pick,
go
we
for
have
it,
to
if
just
you're not
cut
just
off
for
all
fun,
of
I'm
our
not
time,
trying
like what
to.
can we get?
No, for my career, no.
I think you don't want to get caught up too much in making something that's complex for the sake of being complex.
Yeah, that's what I mean.
Like, it matters a lot more that it's multi-based and that it actually works.
Maybe,
Yeah, so what was the minimum viable product for whatever?
So I guess,
I mean, I shot there.
it would be something that can detect if a child is in a pool, or if a child is wanting to
I'm in Midtown, but that's like the closest Walmart.
or is not. When since for
I think if we just want to make a proof of concept, we don't actually have to use like a child in the pool. It can literally just be like,
So it's like that one or it's almost.
we'll just say a person in the pool and they've been in the pool for more than like 5 seconds. And we'll say this is the proof of concept that instead of if we were to train on a child instead of whatever.
But yeah, that's man.
I wouldn't say best one, like.
I mean, you get to hang out with these guys.
Just because that was.
That's what I'm saying. That's what I'm saying. On the presentation,
Camera
let's
out and
say,
code.
on the proof of concept, we don't.
But it's like, everything, it's like, if they can't even do it, it's like, then what's differentiating our applicants?
Yeah, I mean, as long as you want to. This one's, all of them are kind of different too, so like, that one I did one 2 weeks ago, and that's like youth and college. So it's like all years, right?
A lot goes off.
But then like this one is out of the entrepreneurs thing at Sac State, so you know, it's like an entrepreneur base.
So.
And it's college students only.
So,
So that's,
I think we
it's
should
gonna be way different
just
than
have it if the baby's in the back.
doing an event where it's like all ages.
At all.
okay, so, yeah, so depending on how it works.
So there's, I mean, if you go to the website on,
Like ground protection, they have like actual hardware running,
there's all
like,
kinds of different ones.
in like physical proximity to the actual campus, right? So it can actually run like on the campus system.
Find something for you.
If we're doing it where the AI
Like low code
we have to
ones.
stream video footage, there's obviously going to introduce latency, which is like a potential problem. Because not only do you have to keep the video from the camera to the AI, but then you also have to stream it to our front end.
Yeah.
So that's like,
I mean, you
so
can get
you're
it
adding
from
quite a bit of.
Well, I was thinking the
Like it's the future.
So like, how do you?
No, it's more than just demo purpose, the front end part is full force.
Well, that's implementation.
Yeah, it's easier.
It was like this, but then.
I think you just look at
us, we use like.
I would bail out to
on-site.
Well, I mean,
Not
my point
to
is,
but yeah, I'm at Arizona.
the idea is not to make it like, get it.
You gotta hang out.
I guess,
It could be.
For every meeting.
But for demo purposes, we're using web.
Stay safe, yeah.
I think just
Basically, when a baby is in
I guess I should say.
of drowning, it's like drown
Say,
protection. So
say, I should say.
my presentation is based off of the
Say
leading
mean.
it is the leading cause of death for babies.
Thanks for coming through.
Is drowning. And so, basically how my system works is the moment that a baby touches water, you can assume that it's in danger of drowning. And then it will send an alarm and then have emergency.
So there's gonna be like sensors across the pool, basically?
Not across the pool, so you would train the,
I'm saying, using AI to do that.
so you would train the AI model to recognize a baby and then when a baby is in contact with you.
That's pretty cool.
Thank you. What about you?
Alright, so.
So you guys are going with like one project basically?
We're trying to decide. So, my idea is that, I have to give some context. So, in the healthcare industry, like, oftentimes, there's two instances where my application is applicable. So, the first one is that in the healthcare industry, a lot of the time, there's a problem where, like, when someone is done a treatment, right, and they go home and they have to take their medication, the doctor can't, like, make sure that that person is staying on top of their medications. And for elderly people that don't have like a caretaker at home, that's like an additional thing to track, right? So my app idea is to bridge that gap and like, I guess provide that data to the healthcare provider.
A statistic, how many people
like-
are actually doing it?
Yeah, how many people are actually doing it, but we use AI to make the process easier. So the application is basically just like an agent that you can talk with. Like just you open an app and you literally just talk to the AI agent, and all of the information that you're relaying to that agent can go to your healthcare provider, and then you can also use the application to like, so let's say you have a bottle of pills, right? And or maybe you're like your heart division or something. You can use the application to like take a picture of the bottle or take a picture of the specific pill because pills have like little engravings on them that identify them. And it also uses AI in that instance to classify the pill and make sure you're taking the right one at the right time. That's basically the idea.
And then-
My only problem with that would be like older people don't really know how to use their phones. Right? Older people don't really know how to use apps.
Well, that was the point because like
Would they
older
get trained
people
on it?
don't know how. Well, the point was like elderly people generally aren't that like adept with technology, right? So, like, I guess the point is we want to make the process as easy as possible. So rather than having to plug in a bunch of information onto your phone, it connects directly with your health provider. And literally all you have to do is press like one button. You just open the app and then
Okay.
press one button. You talk to the assistant and you don't have to do anything. The assistant tells you what to do and helps you like understand like what medications you need to be taking.
I got it.
So they're both good. So
Oh, yeah,
honestly, it
they're both
doesn't
good.
really matter.
I think they're both like beneficial for society. I'm trying to think of which can make the most money, bro.
I'm trying to think.
Hey,
Hornet hacks is
If you
easy.
learn
That's how you make
and,
money.
it was kind of cheap, and we're not really trying to implement it. If you think about like heating costs, right? Let's say if the weather's outside like hot, on a hot day or whatever, and it's like 3 to 7 p.m., like those are peak hours for energy usage. So then I was thinking using AI to calculate the thermal mass of like a room. So then it knows that like it costs this much energy to heat up and cool this room and stuff like that. And then calculating that with the weather, with the how fast it takes for the room to heat up, slow down, as well as the cost of the energy. You can calculate what's the best time to heat or chill that room, so that you still get the benefits of an air conditioned room and all that stuff. And you're saying about money and stuff like that. This has been proven before in commercial settings, and they're using like warehouses and stuff like that. And in the commercial setting, that's like about anywhere from 15 to 40% energy savings. So I'm thinking if you use that, then we can put a couple of sensors in the house, And then you'd be able to say maybe 10-15% every single home that uses heating and cooling.
It's like that cool.
Actually being able
I
to
kinda
hear
like
the
your,
ideas instead of like seeing them on Discord makes it like, I can actually like visualize them
The
a
thing
lot
I'm-
better, you know?
Okay, we're kind of like still on the drown guard, the pill scheduler.
I kind of like your.
The thing I don't like about that one is that it's basically a fucking AI assistant. That's the thing that bothers me. I'm sorry.
But it's like,
There's
I mean,
no
but
part of
my,
that.
okay, my rebuttal to that is what's wrong with an AI assistant? If it
It's
provides
not, but then if
utilities-
we're gonna go to like a hackathon, you kind of want to compete, right? I wouldn't want to go something that seems so like simple, I guess you could say.
But like, okay, think about it though. Cursor is an AI assistant, and Cursor is used in production, like.
Right, but
by the senior software
you
engineers,
still
so-
say that's like almost a chatbot kind of thing. You can use like GPT to do that.
But-
And then you're saying on
Yeah,
your
sure.
thing, you pull up your app, you talk to your AI. What difference would that be if I just pull up my phone right now and talk to Gemini?
Because it's faster and actually interfaces with health APIs. Because like what's the difference between Cursor and ChatGPT, right? Like, I mean, I guess they both use AI, but like,
Mhm.
there's still a reason why people use Cursor, because it provides additional utility on top of the pre-existing AI, right?
Okay.
It's not always about reinventing the wheel, sometimes it's about reusing things.
So it's between
that
those
makes
two?
it useful for
Why don't you
someone
just take the vote right now?
That's what we're doing.
We got tired.
I'll write it on the board.
else.
I mean, for the code scheduler, are you open to using computer vision to be scanning
I
them?
mean, I think we should go for like a minimum viable product and we have time to add features like that.
I don't mind if we do things archives, or the way, they're not the, thing like that. but-
You know, I had an idea for our for what it's called, so you can call it like poolside. And the O's are eyes.
Ah.
What do you guys think? Yeah, we should use that.
Who wanted Vegas to drown?
Interesting game.
All right, so raise your hand up for drowning babies.
Is that a
Oh,
rock
yeah.
band?
1, 2, 3.
Actually, why are you not raising me?
All right, now raise your hand up for old people.
Wow, you guys don't care.
And I'll raise my hand up.
I can't vote for myself.
Well, let's further that, guys. Just-
I know, I've been listening, it's just.
All right, raise your hand up for old people.
Can nobody take a picture
All right,
of the board?
I'm gonna include you in now. All right, so,
Are we saving the
are you
big
guys gonna save some babies? Or drown them?
Are you guys cool with that?
I just hope they don't ask, like, what if,
Like,
what if
as long as
your
we follow
program
that, I'll put
fails?
them in.
And the victim drowns, what do you do then?
It's not, he's on another team.
Both sides.
Yeah, we won't be able to capture every frame live, but then
So I
maybe
think
we could,
yeah.
we'll just capture some frames, or maybe slow down the interval so that's, so that we'll still be able to track the babies.
I think, well, we shouldn't be doing tracking for when the baby enters the water, but instead it's the baby's in the backyard or in the area of the
They're getting
pool
close
at
to the
all.
water.
Yeah.
Because an unsupervised baby is already.
So you want to do like a proximity thing, like if they get closer,
Yeah,
it eats louder.
I think that's a good idea. Prevention is better than.
Yeah,
Actually,
yeah,
if
because
they're
they're in the
water
one.
ready, they got 10 seconds.
I'm sorry, yeah,
at
you got
most.
like
Yeah.
10 seconds, but if
Yeah.
they're in the backyard, you get a notification, baby in the backyard or something like that, or another common notification, the baby's getting closer to the pool in the
Yeah.
backyard,
Actually,
that's prevention.
I like that.
I think maybe we should focus on prevention
Yeah.
more
Yeah.
than the baby
Yeah.
in the pool,
Yeah.
because, like, I was gonna
I
say.
think that'll also be
Yeah, I
easier
think
for
what
us to do.
differentiates-
We'll train it for like.
Otherwise, what differentiates our app? Because like I was reading about this other one, and it does the exact same thing, and you can also specify the time intervals for like how long people are in the pool, and you could just put it at 0. So like as soon as someone got in the pool, it would go off, which would be the exact same thing,
Right.
right?
Well, that's where the computer vision will come in, because it will be able to identify if it's like a person or.
But I mean, they're,
When they
that's what I'm
train
saying,
like
is they're- that already
based off
exists.
bodies of water and like measure distance, so
But,
once
like,
they
I
get
like-
within
I
a
like-
certain
So,
distance.
The point of
then
the
it will go up.
computer vision was to train the model of whether to detect whether it's an actual baby or if it's like a leaf, like rolling down.
I think the preventative thing is actually, I think that's the cool thing. Like,
That's a good
imagine if
idea.
like you could do like, let's say there's like a parent outside, outside the pool and the kid. Okay, like there's a parent, so we don't need to set an alarm. But the parent leaves, then you get a notification saying like unsupervised
Yeah.
baby.
So it would be
That's
more
what
of
it's all
an
about.
app-based then.
Yeah, because you
I
guys
think
will
you
send
can scale it
notifications,
so
but
that
they still
it's
need to access to
stable.
some sort of camera to see, but you get like notifications or anything on your
That's
app.
nice too.
Or if the baby's actually in the water, maybe there's like an alarm. But, I guess for us, just for right now, but sending a notification to your phone, hey, unsupervised child in the backyard.
I think
you're like,
alarm would
Right.
always be better.
Yeah,
If
alarm.
they're like within like 10 feet,
Yeah.
alarm goes off.
Baby in the backyard, something like that, so. But yeah, preventative, I think will be a lot better. It'll also make it easier for us detecting a pool, and two, a child in the same area. So that'll make it easier for us for computer vision.
Okay.
Because if, for some reason, if the camera's like, let's say, really low quality, we can't, and it kind of blurs together if there are, in the pool or something. Splash it
So
out.
do we want to keep the pool? Because if you think about it, we can have this on street camera, and the kid starts crossing the street, you know? So we can expand the scope to beyond this.
It can be expandable, but.
Probably use that in your zigzag.
Start with one. I think we should start with the pool just because our statistics are like, what?
Yeah, I guess, for your idea, I guess like, yeah, we start with the pool and maybe in the presentation we can do like, we can also use this
Yeah.
for like streets.
Yeah.
Or, things like that, like streets where you have a camera in the front yard and if it detects, a child in the street. But I guess we need to consider, like people walking by, but yeah,
Yeah, that'd be way harder to.
yeah, that'd be way harder to
And if you
implement,
try to
but,
access the street camera, then you need like government permission and shit like that.
well, no, it'd probably just be like a front door camera.
Yeah, kind of like a ring kind of thing, so it'd be like more of a private property kind of like that.
But, it's just ideas.
Yeah.
But I think for,
All right, well,
something that we need to be.
conceptually, like, it sounds like we kind of have it. How do you guys want to start it though? The actual hard, like, work.
So
We need to research on how to do computer vision with
There's
Python.
streaming, there's, which is like where we capture the frames, then we have to send that to the model, which we have, that's something we have to train on some pictures.
There's some protocols and Python libraries that can help with that, so it's just a matter of implementing.
There's like OpenCV
Mm.
for video streaming.
Yeah.
I think it captures like, it could capture like 3 frames per second compared to real times, 30 frames. So we'll still be able to see mostly what's going on.
Yeah, there's always TensorFlow.
That's for training models, but then,
You can only just use a pre-trained Python, so.
I think we're gonna have to pre-train this our laptops.
I think there's probably, things out there that shows like a bunch of like, empty pools or something, or like baby pools, or like that, I don't know.
Who's gonna be there?
So, I don't know. So
I have
tomorrow,
so I can't.
I think I'll be there by
I can't
9,
believe it's
maybe
tomorrow.
10. Nine to 10, because I'm gonna take the bus, so hopefully the bus shows up on time, hopefully I wake up on time. So, but, yeah, that morning I will be there, I'll be there.
Yeah, I'll be there at 9 too.
I could be there the whole time, but then, I might have to take some pauses for work, but
Yeah.
otherwise.
I just have to do my meeting.
Yeah, I'll be there in the morning.
I do know
I'll
everything.
What about Saturday? Everyone's good for
Saturday, I'm definitely good for Saturday.
I'm trying to finish some coursework, so I'm just dedicate a whole weekend for this.
Yeah, me too, man.
I mean,
Sunday also, I
it's
think I'll
all
probably be
day,
taking the bus
so
if you're not asking for
you could
it.
assume
I
like.
had 2 midterms to take care of.
Let's just take.
No, I'm just saying, like, it's all day, so
breaks.
you assume like you were gonna like go study for a few hours or
Do
whatever.
we know if, food is provided?
Yes, I read it, food is provided. I'm not sure for breakfast, but I know they'll have for lunch.
I got, a message from the Discord guy about the parking pass, and he said
yeah.
they talked to him, mailed it to whatever service. And he said he's gonna email us like the parking pass.
Okay. So yeah, I'm gonna parking pass and I'm taking the bus and stuff.
Yeah, I'm pulling up on transit. You were pulled up on transit?
Yeah, the bus.
At 65th or? No, right to the front.
Taking, what, 62, I think is one of the buses I'm taking. And I'm transferring, I'm still looking at Google Maps to figure it out.
It's pretty
Ain't
easy.
gonna need to
It's
link
easy
up
to
at-
get there. Just be like right off. And like
Yeah,
all
I
the.
think about what, 7, I think? I think
Well,
you
we'll
know,
have-
be ready at 7 outside. Gosh.
That's still sealed.
Hopefully.
Yeah, I think that's a good idea what you guys came up with, there, the baby stuff is a big market.
Yeah.
I think it's cool.
I think it's
I think
all
your
pretty
name needs a little work, but good
I don't
idea.
know what you're talking about.
Drowning baby.
I feel I had better
I
implementation.
think,
so-
I think poolside is probably a name that's been taken, but like.
Well, yeah, obviously, you don't wanna name it
Good idea.
Drowning.
But yeah,
Is there
I mean, you have to do a big
Definitely,
deck, and
I
if you
mean-
win first place, they
What's
want
like
you
a
to
good-
pick
I
it
feel like it's
to
been taken like.
the upper
Drowning
division.
20
Drowning
different
prevention.
rules.
Slide AI.
Yeah, it looks like that's already a thing.
Because if you prevention, they want you to pitch
Right.
up to the
I
next
don't think it's
higher up
it's
division.
something else.
Like AI drowning prevention.
Like,
I think that's what he's saying.
I mean, I figured out new now.
Drowning babies.
Get it on market.
When we are not liable,
right?
if you use our service, and your baby drowns anyway. Yeah, we are not liable
It's
if your
marked as
baby in the
non-emergency.
backyard
Like,
drowns
like-
while our service is active.
That's a supplemental.
This is a,
Mental service, please keep watching this.
yes, this is not,
300
It's
frames
not a
per
lifeguard,
second.
it's not a babysitter.
yes.
Streaming shouldn't be a
You guys are your
I've
children at
seen
all
them.
times.
Political atmosphere.
What,
I don't pay attention to that stuff, man. That's the
so
first-
for a web app, and then, yeah, I think so, yeah,
So
Flask for the backend.
This is a subject we would go for.
Well, I think
What's a deliverable? Like,
we
what
need
was
to
the
show a
deliverable?
product, right, and I think of making us some sort of web app where we just use, make a website with, yeah. Because I think making a phone app, it requires different technology with Python.
But how
How
do
do
we
you
gonna
use, well, if we just have an API that's just like serving our data, then we can just use the app to make a web, or a phone app.
How are we gonna, show the notifications through the web?
I guess if we did that, we could just use SMS, like just send a text to your phone, instead of an app notification. But if we use React Native, I think we can just do app notifications.
SMS takes time.
Have you guys used SMS stuff before? Is there a free service?
Just, I don't know,
There's-
there's a library.
Probably like
of
a-
Probably things that can send messages and everything.
You have to pay, like, you want more, but for proof of concept.
I've always wondered.
Okay, well, we have an idea, so.
Yeah,
Well,
I guess. Well, we're gonna be, at
Let's
least
go
tonight
through the-
researching, computer vision with Python and.
Well, the hackathon's not just the code, it's also like the presentation, so, I mean, that's.
I would be
I hope-
comfortable with presenting.
Yeah,
I'm
I'm
good.
good.
Like, maybe
I'm
on
good
the
with
slides
that.
and stuff too.
Shouldn't be like a group thing.
Yeah, I mean, yeah.
Presentation, I think it should be.
And we're all gonna be up there, but it's like
Yeah.
just doing the pitch.
I'm very, very proficient in presenting.
I think it's honestly, I think it's better if everyone talks a little bit because,
Yeah, yeah.
like,
I mean, I'm not probably.
we didn't want to, no one wanted to talk to the last one, but I was like, I don't know what you guys are working on, like, your day, like, all I can talk about really is like what I did.
Oh, no.
So I was like, I don't know, it's just like, I was working on like
You
ES.
should use the word
stuff.
"we" a lot during the
Yeah.
presentation.
Also,
We saw the
test
French
really
people.
good with me. Like, that's something that my team had problems last time. We didn't test a lot, and then we started putting stuff together, and then it just was not working, and it was like.
Should we create a GitHub, today or tonight?
Yeah, maybe that's fine.
Yeah, we should definitely, so then we don't have to worry about that tomorrow.
I mean, technically, we can get started ahead of time, because it doesn't have to be full money.
That's true.
Yeah, especially since we're more inexperienced than a lot of the other teams.
Did they look at your, like, GitHub repo though?
They say you can bring in like whole projects.
What? Yes, you just make the whole thing?
Yeah.
You could.
Yeah.
You wanna do it?
I mean, that's kind of why I think we should plan ahead of time, especially when it's Ted's
Like,
intern,
you're
right?
working on it the whole year, and here's the project.
You technically
No,
could,
but they
like-
said you have to tell them what you've done, like,
Oh,
what you
okay,
brought
okay,
in.
okay,
stuff like
okay.
that.
I
So
was
we
about to
bring in
say-
like our GitHub repo and everything, that's fine. But,
Okay,
like,
okay.
Yeah, so GitHub repo is just
We
a
can-
Flask.
We can
just
figure out like,
already?
you know, whatever, finish our readme, everything like that.
How are y'all gonna split up the work?
That's a good question.
I think.
And then
I can work on streaming.
streaming, and then the computer project.
Probably get that sorted out.
Yeah.
To start.
Yeah, the
doing a
model is
little bit of
separate
research
from
on it.
streaming, so I'll give you a frame and then or like an image, and you have to determine whether it should raise an alarm or not.
So I guess I'll work on, back end with the communication between all the different parts. Which is,
Like, so you're
which
making
is a big
APIs,
part, honestly.
So you
I'll
have
look
the
at it.
API?
Hmm?
or the Flask API, so that like connects to the services.
Yeah. Okay.
Is that all there was? You got like multiple people working on the harder stuff.
I mean, I don't have a lot of experience with like this technology, so I'm.
We need a front end. Well,
If you can help me with the back end, that'd be nice.
Yeah, I mean, if it's just writing functions, I can probably do a couple of them.
Back end.
You can probably just, there's at least, you
Work
can,
front end.
at least tonight, and just try to watch, what, like 2 30-minute videos just explaining the general concept of Flask.
Yeah, if you can just like get the hang of like what routes do, and like how to make all the routes, and then maybe a little bit of video.
I can help with that too.
Because
That way.
I just want to make sure I have a
It was
good
like-
portion of the project and I just like doesn't feel like I'm being
Yeah,
carried.
yeah. I'll
Don't
post it.
worry about not having experience. I still haven't disclosed my secret, but
What's your secret?
I might talk about it later on in the.
It's all good, man. Your secret's your secret, man.
Yeah.
Plus,
Bro's been working for Google for
He's got one of the
20 years.
It's on YouTube now, buddy.
Yeah,
Yeah,
just
it's
keep it
good.
to
Yeah,
yourself,
it's
man.
good.
He's like Amazon
Ace up your
optimizer.
sleeve, you know?
He has personal connections with Jeff Bezos and stuff.
If you have
Yeah,
Exodia,
I'll
you
talk
keep
about
it
it
to
more
yourself,
later.
Exactly.
I mean, I don't know what I'm doing.
You got
I'm an
Bible,
English
right?
major. Right, Gideon?
What's that?
English.
Thank you.
Ah, man, geez.
What's that?
We're fighting over the same
I will
bunk.
not take it.
At the home.
Yeah, it's just like we're getting a lot of data and we have to process that and display it on the, and we have to find a nice way to display it.
Yeah.
What do I have?
So for the what, front end?
I'll tell you what you're doing.
I think there's something called Yellow 8.
Yellow 8.
Yeah.
That's for the, is that for part of, YOLO? That's the boxes, so that's part of the mod,
Yeah.
model.
So you said you're doing front end, so I guess that would be, well, I don't know how you would do front end for a mobile app. I don't even know for web apps.
I'll try to figure it out.
I mean,
I've never used React Native.
As long as it's not
you can make a
So React
web
Native?
browser, that's enough, because
Yeah.
It
As long as
has,
it's not like
graphics.
It's literally like
No, React
NPM
Native.
start. It's giving you
React
the
Native is a
window.
framework for like
JavaScript.
cross-platform mobile applications.
Doesn't it stem from JavaScript?
It's a JavaScript library.
So you can create,